This is the property of convolution computation. For this one, this is also based on the previous linear convolution equation. So if we use this equation where yn is equal to the summation of hk xn minus k, meaning that in this equation we shift the signal of x. If you use the other equation, the summation of hn minus k multiply with xn, meaning that we will shift the value of h. So in this case, we will shift the value of x signal. So the process of computing the convolution between xn and hn involves the following steps. The first one is folding. Since we want to shift the value of the signal x, we need to fold x signal. In this case, we label as k. We fold this value, the signal x, about k equal to 0 to obtain x 0 minus k, where 0 is n, the integer of signal x. Okay, after we fold the signal x, we have to do shifting. We will shift by n to the right. Okay, it depends on the value of n. If n is positive, let's say x2 minus k, we will shift x signal to the right by 2, since 2 is positive. So we will shift signal x to the right by 2. And we shift by n to the left if n is negative. For example, this is -1. So we shift signal x to the left by 1. The third one is multiplication. So we need to multiply the shifted value of x with the original signal of h to obtain the product sequence we label as vk, which is equal to this one. Let's say we started with vk equal to 0, so this is v0, and then we increase by 1, so we have v1, and v2, v3, v4, and so on. And the last one is summation. We sum all the values of the product sequence vk, v0 plus v1 plus v2 plus v3 to obtain the value of the output at time n.